Hello and welcome to our next set of college algebra notes. We are now on outcome 2 for unit 2. I told you last time we're going to see some complex numbers, so you will see those show up again today. But our main focus today is to solve some equations. And you're like, we already solved equations. We did that unit 1. Yeah, so these are going to be a little different. These are now quadratic equations. Quadratic equation, that's just a fancy word for an equation with an x squared in it. The stuff we were solving last unit typically had just a plain x, no x squares, something like that, bx plus c, we could solve for x. Now we're going to solve equations that have an x squared in them. It's going to be our next step. Now when you solve equations with x squared, you typically can't just get x by itself and solve it. You typically have to use some fancier techniques. One of the most important techniques, one we'll use all semester long, is factoring, where you write it as a multiplication. You take the expression, turn it into a multiplication, and then solve using that. Now to do that, you're going to have to use what we call the zero product principle. So the zero product principle, it's a big deal, it's an important principle, says that if you multiply two numbers and get 0, then you know that one or both of those numbers have to be 0, and vice versa. If one of those numbers, if the first or the second number or both of the numbers are 0, then they will multiply and give you 0. This is a little logic statement that says this works either way. You know, sometimes something else equals 0 means that one of them or both of them have to be 0, and if one or both of them is 0, then they multiply to give you 0. Now that's important because if you factor, if you take a quadratic and you write it like this, where you have it as something multiplied, right? Parentheses next to each other means they're multiplying, equal to 0. Then you could just take and you can set both parts equal to 0. Because when we're solving an equation like this, we're looking for all the numbers that make it true. So if this expression, x minus 5, if it's equal to 0, then 0 times this expression will give us 0. So if that's 0, we're happy. If this expression, 2x plus 3, if that's equal to 0, then that times this first one, 0 times the first one, would give us 0. So if either one of these are 0, we're happy. So we'll find equations, we'll find solutions for this equation if we find the two things that make this one and this one 0. So we're going to set x minus 5 equal to 0, and we're going to set 2x plus 3 equal to 0. And we're going to typically find two answers when we're solving quadratics. It's one of those quirks of quadratics. They typically have two solutions. Don't always, there are some exceptions, but most of the time they do. Okay, to solve the first one, I'm just going to go ahead and add 5 to both sides of this equation, because adding 5 is the opposite of subtracting 5, and those do cancel. So we get x by itself, and over here we just get 5. And you can see how 5 works, right? If I put 5 in that expression, 5 minus 5, this would be 0. And then whatever this is, 0 times it will give you 0. So the 5 would make this work. Next one, we're going to solve this one. We're going to subtract 3 from both sides. Get rid of that plus 3. So we get 2x equals negative 3. And then we're going to divide by 2. You always want to do multiplication with division, not with subtraction. I've gotten students in the past who try and subtract 2. You can't subtract on multiplication. You have to divide. So divide by 2, like that. Get the x by itself. And then negative 3 divided by 2. It doesn't come out nicely, so we'll just leave it as a fraction. So negative 3 halves, or negative 3 divided by 2, would be our other solution. And you can check that out as well. If you put negative 3 halves in here, well, 2 times 3 halves is just 3, right? So the 2 on the bottom would cancel out with a 3. And so negative 3 plus 3 would equal 0. You could actually put that in there and it would work, because 0 times anything would give you 0. So that's the idea. Both of these numbers are solutions. 5 is a valid solution, and negative 3 halves is a valid solution. Those are both answers. Sometimes you'll see my math lab have the answer set, and they'll put the little squiggly notation. Remember, that means the roster method where you list the answers. If you see that notation, they don't want the x's, they just want the numbers. So that's how they tell you they want the 5 and the negative 3 halves. And the order doesn't matter, but you do need a comma between the two different numbers. So you ever see that in my lab, that's how you'd write that. I'm not picky on the test. You can write it like this, where you just box the right answers. You could put it like that, that's fine. I'm not picky. So as long as you tell me what x is, the two different values that work for x, I'm happy. So this is what happens if you get it factored, if you get it broken into multiplication, you set both parts equal to 0 and solve. But most of the work when you're solving these is actually that first step of taking an expression that you originally looks like this or like this and writing it as a multiplication. And we do that, again, by factoring. Factoring is just a fancy math way of saying write it as a multiplication. Instead of writing it like as something added like this, we want to factor it into multiplication. Now these are typically going to factor into an expression with two parts times an expression with two parts. That's what we're going to see most of the time, these two parts in each thing. So there's going to be something, two parts in here, and they'll multiply and give us 0. Now, how do we figure out what goes in here? Well, first off, I know that when I multiply these things, if they have two parts, we're going to multiply them by foiling. And when you FOIL, you always do your first times your first, and you get your first thing up here. This times this will give us x squared. So we know that the first two parts have to be x's, right? Because x times x is the only way I'm going to get x squared. So I know I'm going to have a couple x's in there. And then I know the other parts usually multiply to give me my last part. So this times this is going to give me 6. So I know they're going to multiply for 6. Now, why don't I just tell you it's 2 and 3? Because it could be 1 and 6. I don't know which one it is. So I know they have to multiply for 6, but I don't know if it's 2 and 3 or 1 and 6. I also don't know, maybe it could be like -2 and -3, or -1 and -6. I don't know that yet. But I do know that after I FOIL, typically my next step is to combine middle terms. So because I'm going to do like my outer and my inner, I'm going to have two things that with x's that add up to get the middle. So I know that the two things I end up multiplying are going to actually add up and give me 5. So I'm going to multiply for 6, but I'm going to add for positive 5. So I look at the two options, I say, well, 1 plus 6 is 7, so that doesn't work. So my answer is 2 plus 3, right? 2 and 3, because x plus 2, x plus 3, they multiply to give me 6. So you can say, do your last, you do 2 times 3, you get 6. And when you do the outside and inside, you get 3x and 2x, which combine for 5x. So you can see how you get this expression. So this is factored. So we factored it into two parts, and usually do this by thinking what multiplies for the last term and adds for the middle. And this is going to be probably the easiest way to solve quadratics. Factoring should be something you've seen before. If you took Math 101, intermediate algebra, you should have seen that in that class. If you took algebra in high school, you should have seen factoring in that. If factoring is something you're not comfortable with, I highly suggest going on Khan Academy and just Googling their factoring lessons, doing some practice, because factoring is something that we're going to do a lot of. You'll get some practice with the notes here, you'll get some practice, you'll get a lot of practice in the homework. It's a pretty heavy thing we do all throughout the rest of the semester. So you should be comfortable with it. If you're not yet, maybe practice a little bit, but because we're going to use it. So if I can, I'll take an expression like this, I'll factor it, and then once it's factored, written as multiplication equals 0, I set both parts equal to 0. So I'm going to take x plus 2, set that equals 0, take x plus 3, and set that equals 0. To solve this, I'm going to go ahead and subtract 2 across. Subtract 2 from both sides, so get rid of this plus 2. So I just get x equals -2. I'm going to subtract 3 from both sides, so get rid of this plus 3, and I get x equals -3. And so those would be my two solutions. And you can go back, you can check these, right? You can go back to this original expression, and they should work. If I plug a -2 in there, -2 squared is 4, -2 times 5 is -10, and 4 minus 10 is -6, plus another 6 is 0. It works. If you don't trust me, you can write it out. Same thing, if you plug -3 in there, it will give you 0. These are my two solutions. And again, I'm fine with just telling me the answers are -2, -3. My lab might be picky and have you writing that notation, but just watch for the way they have an answer. Usually they'll put the squigglies there if they want you to write it that way. So those would be the two answers. Those are the two numbers that make this solution true, this equation true. They are solutions to this equation. Let's try one more like this factoring, and then we'll talk about other methods. Now this one's a little trickier because first off, you'll notice there's something on the other side of the equation. And when we talked about the zero product principle, we called it the zero product principle because this rule only works for 0. What I mean is, if you want to multiply and get a number and say that one of those has to be that number, 0 is the only number that works for. Any number that you pick otherwise, so you pick like 6. If two things multiply for 6, they don't have to both be 6. One could be 2 and one could be 3. And you say, oh, well, pick a hard number, Mr. Algebra. Pick like 5. And I say, okay, well, two numbers multiply for 5 doesn't mean that either number has to be 5, because it could be 2 and 2.5. Those multiply for 5. So there's no rule, there's no other number this works for except for 0. So this factoring technique, where we factor it instead of equal 0, only works if it's equal to 0. You have to have it broken and equal to 0. So if you ever see something like this, the first thing you should do when you see something like this is you should get it equal to 0. Factoring does not work unless you get it equal to 0. That's the first thing you should do. So what I'm going to do here, I'm just getting rid of this 5. Not a big deal. I'm just going to subtract 5 from this side. But if I do it to that side, I have to do it both sides. Equations, you always have to work on both sides, keep the equation balanced. They're like a balanced scale, and you keep it balanced. You don't want to take away 5 from that side and have it unbalanced. So I took away 5 from this side, but I also did it over there. So this ends up being 3x squared plus 5x minus 2. And now that's equal to 0, now factoring will work. But the factoring we did last time won't work because this one's a little more complicated. What makes this so much kind of complicated is this extra number 3 out front. Last time we did it, we just had x in the front, x squared, with no number in front of it. And that was why it was really easy to just say x times x gives you x squared. But when you have 3x squared, you can't do it quite that easily. So we have to use another technique. So I'm going to show you what we call the AC method. I've always also called it like grouping is another way to call it. So grouping is another method. So you can kind of call it either, but AC method, what we do is we look at the first term, which we like to call A. We like to call the number in front of the x squared an A, and the last term, the constant term, which we like to call C, and we multiply those together. So we take 3 times negative 2, 3 times negative 2, and I get negative 6. And now, instead of doing what we did before, we say what multiplies for negative 2 and adds for 5, instead of doing that, we're going to say what multiplies for negative 6 and adds for 5. It's a little different now, because we're multiplying for negative 6 and adding for positive 5. Now it's different because of that 3. That 3 changed things. We couldn't just work with the 2 by itself anymore. We had to work with the 6 because of that 3 tweaking things. So you can see how it got a negative 6 instead of a negative 2. Okay, so if I think about this, what multiplies for negative 6 and adds for positive 5? Now I might think 2 and 3, because 2 and 3 make 6 and 2 and 3 can make 5, but I need to make a negative 6 and a positive 5. And if I try like negative 2 times negative 3, that gives me a positive 6. So I have to do like one positive, one negative. So like a negative 2 and a positive 3. And when I add those, I'm not going to get 5. I'm going to get like 1 or negative 1, depending on which one's negative. So I actually end up having to work with 1 and 6 on this. Because 1 times 6 can give me 6, and it can give me 5 if the signs don't match. Now because I wanted to get a positive 5, I'm going to make it a positive 6. So when I add a negative 1 plus 6 is positive 5. But negative 1 plus times 6 is negative 6. So this is actually my pair. I'm going to use that pair. Now again, this is different. So I'm not just going to write this out as x plus minus 1 and x plus 6. Again, this stinking 3, just that one little 3, it messed it up so much that we have to do it different. What we actually have to do is we have to take this 5x in the middle and we break it up into both parts. So this becomes 3x squared minus, instead of 5x, we're going to minus 1x because you broke it up into 2 parts. And plus 6x. So you notice these 2 parts, they do combine for 5, right? Negative 1 plus 5 gives you, or plus 6 gives you 5, but we broke it up. And minus 2 equals 0. And this is why I call it grouping. So once we did this, it makes it look like we made it more complicated, but we actually made the problem easier. Because there's a rule about factoring when you have 4 terms. When you have 4 terms, you're allowed to work with 2 parts at a time. So I can split it up and group to group 1 and group 2. So that's the trick. If you can break it up into 4 terms, you can group the terms and work with them separately instead of having to try and do the whole thing at once. Now I'm going to factor the first group. I'm going to look for something I can pull out of both parts. I'm looking for, we call it GCF is the fancy name for it. So what's in both parts? And the only thing that's in both of these parts is an x. So I'm going to pull out an x and think about what would be left behind if I pulled out one of the x's. Well, 3x squared, if you take out one of the x's, it's still going to have an x, so it's going to be 3x. And 1x, if I pull out the x, it's just going to have a 1, so it's going to be minus 1. So I pulled out an x and left behind with 3x minus 1. Next thing I'm going to do is I'm going to pull out a part of this part. And I'm going to pull a 2 out. So I have a 2 out of there, and that leaves behind 3, because I'm pulling out by division. I'm factoring it out. And so 6 divided by 2, I leave a 3 and the x. And then here I'm going to pull a 2 out, but I'm not going to leave a 0, I'm going to leave a 1, because again, I'm dividing it out. So I pull a 2 out, I'm left with minus 1. And if you're doing this right, these parts should match. If they don't match, then you're doing it wrong. So you got to make sure that the parentheses here should match. You can kind of tell, because if they don't match, usually maybe you didn't pull out the right sign, like maybe you pulled out a positive 2, but you shouldn't pull out a negative 2, or you didn't pull out enough. So you always double check, make sure they match, and if they do, then you're doing good. Here I pulled out a positive 2, so I should be good with that. Okay, that's still equal to 0, and we got one more step. So now after doing that, after factoring the groups like that, now you'll notice that, like they said, these 2 parts do match. And since they match, you can kind of think of them as a GCF. So a GCF, again, is the thing that matches, and we can pull out of both parts. Well, they both have a 3x minus 1. So I'm going to pull 3x minus 1 out of both parts, and I leave x plus 2 on both parts. Or I leave x plus 2 because I leave an x and I leave a 2. So you can factor this way. This is called the AC method, or maybe grouping, because we do the grouping step, where you break up the middle term into two parts, and then you group the first two, group the last two, and you factor those, and then you write down what's left by GCFing, by pulling out this matching part and writing down what's left. This is still equal to 0 because all we did was factor it, and that's the way to factor it. Now, I'm not going to make you do much of this kind of factoring. No, I showed you here because I think it shows up in this homework a couple times, but you probably won't see it ever again after this homework. Thankfully, there's lots of other ways to deal with problems besides factoring. So a lot of times I'll see a problem like this, and if I don't feel like factoring, I'll actually just use one of the other methods. I will suggest that you definitely get comfortable with the first type of factoring, because a lot of problems, that factoring will show up, and it is the easiest type of factoring. So it's kind of the easiest method for solving problems. But as soon as a problem gets this hard, I'll show you later how there's other methods for solving it. Now, I'm not quite done, so I'm going to definitely finish this. Again, once you have it equal to 0, we can set both parts equal to 0. So I get 3x minus 1 equals 0, and x plus 2 equals 0. This is pretty easy. I just subtract 2 across, so I get x equals negative 2. Here I'm going to add 1 across, so I get 3x equals 1, and then divide by 3 on both sides. So I get x equals 1/3. And those would be my two answers. And you can go back and you can plug them in, and they will work. If you plug negative 2 in the original equation, do all that, you would get 5. If you plug 1/3 in the original equation, you would get 5. So that would work. Okay, so like I said, this is not the only method for solving quadratics. There are a couple other methods, and in certain cases, some of them are easier. So one of the best, easiest, nicest methods is the next one. It's called the square root property. The only problem with square root property is it only works in one specific situation. So it's kind of like a precision tool that works for just this one thing. For the rest of the time, it's useless. So we like to use it when we can, because it is pretty easy to use, but it only works in certain situations. And the situation where it works is when there's only an x squared and there's no x. In that situation where you can have the x squared and you can get the x squared by itself without x's anywhere else, you can do this trick. The trick is you can take both sides of the equation and you can square root both sides. So I can take this equation, I can square root the x squared, and I can square root the 16 and get the answers. Notice that square roots and squares are opposite, so they do cancel, right? Square root says what times itself, and x squared says x times itself, so it just cancels, you just get x. Over here, square root of 16 gives us 4, and we get our answer. But we didn't get all the answers. If you're paying attention, you'll notice that we only got one answer, and this actually has two answers. Because not only does 4 squared to give you 16, but so does negative 4, right? Because negative 4 times negative 4, a double negative makes a positive. So we actually got half the answers, which is why the rule actually states that when you square root both sides, you need to include a plus or minus. Because you've got to get both the positive and negative version of the answers. So we can take something where it's squared and square root both sides, but if we do that, we have to put a plus or minus in on the number side. As long as you do that, then you get both answers. And we said, quadratics, they typically have both two answers, and that's true even in this case. There's two different answers, both 4 and negative 4 work. So don't forget the plus or minus. It's kind of the biggest, most important thing when you're using the square root property, is you can do it, but make sure you put that plus or minus in on both sides. Now, I did this next one. I want to show you this next one because this one's a little more complicated. Because before you can square root both sides, you do need to get the x squared by itself. I can't square root this right now because there's all this other stuff over here. So you always want to isolate, just fancy term for get it by itself, isolate the x squared first. Then you can square root both sides. So like on this one, I'd go ahead first, I'd add 4 to both sides to get rid of that minus 4. Look at 3x squared equals negative 21. Divide by 3 on both sides. Get rid of that 3, and so we get x squared equals negative 7. Now that I got x squared by itself, right, so I got rid of that other junk and got the x squared by itself, now I can square root both sides. But I had to get that x squared by itself first. So I got x squared by itself, so I square root the x squared, I'm going to square root the negative 7. Don't forget your plus or minus, it says it right there, don't forget your plus or minus, because you put the square root on both sides. Again, the square root and the square cancel. That's why we like this. It's pretty straightforward. Just once you get the x squared by itself, you square root and you just get x done with that x stuff. Over here, I do have to worry about the fact that this is plus or minus a root of a negative 7. So I got to remember that whenever you have a negative inside the root, that's where those i's come from. Remember last section where we said if you have a negative square root, that means that you actually have i's. So we break this up and we actually call this I root 7. So we pull that into root of negative 1 times root of 7. Both the negative 7 to negative 1 and 7. And remember that root negative 1 is I. So this would be plus or minus I root 7. Those would be the two different answers. Again, I like to put the I in the front. It's just a little bit safer than putting it at the end. I told you those complex numbers are coming back to play. This is the only time, but they do come out to play throughout this rest of this unit for sure. So, okay, so square root property is great, but it only works in a certain case. So a lot of times you end up using factoring instead, if you can. Situations like this one, where there's x squared and x, you can't use the square root property, so you got to factor. Now, eventually, a mathematician, a really smart mathematician, said, I like the square root method really well. I think it's really slick. It'd be nice if I could take all kinds of problems and use the square root method. And because he was a clever mathematician, he figured out a way to do that. So you can take any problem, you can actually turn it into a square root problem where you can do the square root property. And we call this technique he developed completing the square. So what we're going to do is we're actually going to rewrite the expression we start with that has both an x squared and an x as an expression where it's something in parentheses squared. So we want to rewrite as parentheses squared. Because if you can get it as a parentheses squared, then you can square root both sides and get rid of the square. It doesn't matter if it's more than one thing. If it's a parentheses squared, if it's something like that squared, the square root and the square you can still cancel. So the way to do this, how do we do this? Well, we take an expression like this, where it has an x squared part and a 6x, the number part. And so first thing we're going to do is we're going to take the 6 part, the number in front of the x, the plain x, and we're going to divide it by 2. So I'm going to take 6 and cut it in half. I'm going to divide by 2, and I get 3. Not done yet, because the next thing I'm going to do is I'm going to take that number, and I'm going to square it. So take 3, and I square it. And this number is the number that completes your square. So if I take this expression and I add on a 9, so if I take x squared plus 6x, and I add on a 9, this becomes what we call a perfect square trinomial. And that's where those big, long math terms of things, ways of thinking, saying that this is something where we did a FOIL of something times itself. We actually took something and times itself. The two things match, so you could write it as something squared. Well, what is the something? Well, if I go back to my factor and I think about, x squared at the beginning is going to make these both be x's. And then I need to multiply for 9 and add for 6. Well, the things that multiply for 9 and add for 6 are both 3's, right? 3 times 3 is 9, 3 plus 3 is 6. So notice that the expressions match. If you factor this, you end up with the same expression twice. So instead of writing that twice, I can just write this as x plus 3 squared. So this is actually how it factors. So we completed the square by adding the 9. We completed the square by adding the 9 there, making a nice perfect square so that when you factored it, these two things matched, and you got an expression squared. Now, if you want to, if this was an equation equals 0, you could just square root both sides and get rid of that square. And that's the completing the square technique. This is what the clever mathematician back in the day figured out. He said, okay, this is my trick, this is my technique. I'm going to take my expression, I'm going to figure out what number to add in. I'm always going to divide by 2. I'm always going to square and take it times itself. And then that number is what I'm going to add in. It'll always be positive, right? When you square, you get a positive number, so that's why I always add it in. Whenever you're subtracting, because we have a positive number once we square. So we'll just put it in by addition. So let's use this technique and then solve an equation. So we'll show you how completing the square technique works. Now, first off, when you get completed the square, you notice we didn't have any regular number part. We just left that, we had that blank. Because what you can always do is if you have an equation with a real number, is you can always just take that number and throw it across on the other side and get rid of it on this side. Because you can always say, I don't want a -5. You always want to have a blank there. You want to have space to put the right number in. Negative -5 is probably not the right number. So we're going to figure out what number to put in there. So the first thing is we're going to get rid of this by adding it to both sides. I don't really care what's on the right side. I just want to get the left side into that perfect square situation. So I'm always going to get rid of that thing first. So get rid of the constant. We call that the constant because it's a number without an x. So get rid of constant first. That's always our first step. And by get rid of, I mean move it to the other side. You get it out of our way. So now we just have x squared and minus 2x equals 5. And I got a space here because I'm going to want to put that perfect number in there to complete the square. Now remember, to find that number, what I'm going to do is I'm going to take the middle term, the number in front of the x, that -2, and I'm going to divide it first, divide it by 2. So I'm going to divide by 2. Well, -2 divided by 2 is -1. Don't add -1 in. That's not the one number. There's two steps here, right? First divide by 2, and then the second step is square that. So I'm going to take -1 and square it. Be careful if you type this in a calculator, you need parentheses because -1 squared is actually +1. Remember, negative times negative is always a positive. If you type this in a calculator without parentheses, it'll tell you it's -1. You know you did it wrong. So you should get +1. And +1 is the number you want to add to both sides. So that's the number I'm going to add here. But because it's an equation now, I can't just add it to this side. If you add anything, you always have to add it to both sides. So that's the trick here. This is the number we add in, but we have to add it to both sides. Now, that's awesome, though, for us, because on this left side, this will factor now the way we want it to. If I think about how this factors, it's going to factor like normal. I'm going to have x's in the front, because x squared. And I think what multiplies for 1 and adds for -2. Well, -1 times -1 gives you +1, and -1 plus -1 gives you -2. So it's going to be x minus 1 and x minus 1. Or we could write that as x minus 1 squared. And if you're doing completing the square, you should always end up with something squared, because that's the whole point. We're trying to get that something squared so we can square root both sides. On the right side, we just add that 5 and the 1 together. We get 6. And so on that side, we have 6. That's okay. It's fine to have a 6 on the other side, because when you're completing the square, you don't need a 0. When you're factoring, you do. But when you're completing the square, you don't need that because you're just going to square root both sides. And that's the trick. So from this point on, now we're using the square root property, where we square root both sides. So I'm going to square root this side, square root this side, and of course the square root and the square cancel, and don't forget your plus or minus. So we end up with this side, the square root and the square cancel, so we're just left with x minus 1. We don't need the parentheses anymore because the square is gone. And this side we get plus or minus root 6. Last step, I need to get x by itself, because now I have plain x, so I can just solve for x. So I add 1 to both sides. Get rid of this thing. So I get x. Over here, I like to put the 1 in front, because this plus or minus I'm using here, I know it seems kind of weird. It means that we have two different expressions. We have both 1 plus root 6, and we also have 1 minus root 6. So we actually have two things going on the same way. You could actually write this in my math out like this. There is a plus or minus button, and they'll take it because it's both ways, both versions of the answer. Or you could write it as 1 plus root 6, comma, 1 minus root 6, and that's fine as well. These are both the same answer. This is just a fast way to write it. If you do enough math problems, it gets really old to have to sit there and write all these expressions over twice just because of the plus and the minus changes. And so mathematicians eventually came up with this plus or minus as just a way to write those expressions faster. Just write this instead of having to write it out twice. So that's why we have that plus or minus. And again, it means both things are happening. You're taking 1 plus that number and 1 minus that number. So that's what that plus or minus does. That's completing the square. So the trick for completing the square, again, you always get rid of that extra number. So we want to make a space where we're going to add in the number to complete the square. Take the middle term, divide it by 2, and square it. And then that's what you add in. You have to do both parts, and then you add in that number. Add it to both sides, so your equation stays equal. When I was first learning this, my biggest mistake is I'd always add the 1 on one side and forget to add it to both sides. I'd forget, oh yeah, I have to add it to both sides to make the equation stay true. So make sure you add it to both sides. And then this should factor into something squared. You get the same thing twice. And then finally you can square root both sides and then solve for x, and you get your answer. So let's do one more completing the square like this, and then we'll talk, there's actually one more method we have to cover. Okay, so we're going to solve this by completing the square. Now, like I said last time, first thing we're going to do, we're going to get rid of that minus 3. We don't want a minus 3 there. We want this empty, so we're going to add 3 to both sides. So we're always going to get rid of that constant part. So I got 2x squared 5x, I'm going to leave a blank, equals, and I got 3. Now, next thing I do is I actually, on this one, don't worry about the 5 yet, because first I have to get rid of this 2. You cannot complete the square if there's stuff in front of the x squared. When we do our factoring part, we always want it to be x's, x times x. If you have an extra number there, it won't work. We saw that AC method factoring we had to do before. We don't want to deal with that. So instead, we're actually going to take everything here and divide by 2. So we want to get x squared by itself. You know, like, I should say, By itself, I don't mean, with nothing on that side, because there's going to be this 5 part, but I don't want to have like this number in front of it. I want to just get the x squared, so nothing in here. Okay, so that's what we're going to do. Take everything divided by 2. That will cancel the 2 here, so I just get x squared. The 5 doesn't divide nicely by 2, so we'll just leave it as a fraction. Yes, we'll have to deal with some fractions in this, and that's when completing the square can kind of be a pain, because sometimes you have to deal with fractions. We're going to leave that blank there, and we're going to say 3 divided by 2 is 3/2. Okay, now we're set up, because again, you can complete the square if you got the x squared by itself. It'll work. Even with fractions, it'll still work. So remember that when you do this, you always take that middle number and divide it by 2. So if you take 5/2 and divide it by 2, nice thing, there's a trick for this. Instead of actually having to divide by 2 and think about that, you can just multiply by 1/2, because dividing by 2 is the same thing as multiplying by 1/2. And if you multiply 5/2 times 1/2, you just multiply the bottoms, 2 times 2. So you get 5/4. Another way to think of it is you can double the bottom. Dividing by 2 is the same thing as doubling the bottom. I do this all the time when I'm helping my wife cook, and she's trying to figure out fractions on stuff, and she's like, hey, I got 3/4. What's half of that? I just double the bottom. 3/8, that is half of 3/4. It's a really slick trick. It makes you look really smart in the kitchen. Of course, when you're a math teacher, you just expect it, so I don't really look that smart, but you guys can probably use that at home. Okay, so we doubled the bottom and got half of the value. So this is half of it. 5/4 is half. And then we take that number 5/4 and we square it. When you square it, you square the top and you square the bottom. So this top 5 times 5 gives you 25. Bottom 4 times 4 is 16. And that's what we're going to add into both sides. Remember, you do both steps and you take that amount and add it in. So we're going to add in 25/16. I know, ugly fractions. It's not much fun. Thankfully, there's another method we'll show here in a second. But this is what you do if you're using completing the square. And we'll add 25/16 to both sides. Have to do it to both sides. And now this will factor. And you're thinking, I have to factor this with fractions? It's not as bad as it sounds. There's actually a trick here. So the trick to doing this, to factoring, is we know that it's going to factor to something squared. We know it's going to have an x in the front. All we really need to figure out is what this number is going to be. And we need a number that will multiply for 25/16 when you multiply times itself, and we'll add for 5/2. Well, the number's actually been on your paper. It's right there. Because 5/4 is half of 5/2, so 2 of them would make 5/2. And 5/4 times itself gives you 25/16. So when you're doing this, you can always look at the number you got in the first step, and that's what's going to go when you factor. So I'm going to put my 5/4 here, positive, because that was positive. You can go back and look at the last page, you can see the same thing worked, right? So here I factored, the number that was inside was the -1 I got in the first step. Or up here, the 3 that went on the inside is what I got on the first step. So it's not what we add in the original place, because we added the second step, but when we factor, that's the number. When we factor, that's the number. So here when we're factoring it, when we're actually, we already wrote it like this way, now we're factoring, then we use the 5/4. Okay, on the right side, I do have to add those. You can pull your calculator out and just type that in, because it will do 3/2 plus 25/16. You might have to hit that math button and turn it back into a fraction. Or you can get common denominators. Here you'd have to multiply 3/2 by 8, times 8 on the bottom, times 8 on the top, so you get 24/16. And 24/16 plus 25/16 is 49/16. So that's what would happen if I add those. I just did it by hand, but if you want to do it in your calculator, it would work on your calculator. Okay. Again, the whole point of completing the square is getting an equation like this, where you have something squared, because now you can use that square root property. It's so powerful and so convenient, because it lets you square root both sides. Don't forget your plus or minus. Don't think a big deal about that yet. You really need that plus or minus, otherwise you lose half the answers. And that lets you cancel the square. You just get the inside, the x plus 5/4. And on this right side, we can simplify this a little bit, right? Because square root of 49, that works, it's 7. Square root of 16, that works, it's 4. So this one actually just becomes plus or minus 7/4. They always come out that nice, but I picked one that was not too terrible because it's just an example. But that's the idea. You can square root and simplify this as much as you can. Last step, I'm going to subtract 5/4 from both sides to get rid of this positive 5/4. So we get x equals -5/4 plus and minus 7/4. Now this problem, we don't get to stop here. Most of the time we got the plus or minus, we got to like stop it at some point. This one can't stop because you can actually do this addition, right? 5/4 plus 7/4, that works. So you can add that. So this one will break it up. We're going to do -5/4 plus 7/4. and we're going to do negative 5/4 minus 7/4. Anytime you can actually do the addition and subtraction and get a nice looking number, you should actually do it. You know, the previous problems we had stuff like roots and stuff that made it too hard. We couldn't do the addition. But here they juggle fractions, so we can do it. So we get negative 5/4 plus 7/4. Well, negative 5 plus 7 is 2/4, or 1/2, because that simplifies. So that'd be my first answer. And negative 5/4 minus 7/4, that's going to be negative 12/4. Negative, you know, remember you add the opposite if you're trying to subtract fractions. So negative 5 plus negative 7, you get negative 12. And that simplifies, right? 12 divided by 4, you get 3, and a negative divided by positive is a negative. So those would be our answers, 1/2 and negative 3. And you could go back, you could plug these numbers back in that original equation, and they will work. They are solutions to this. Okay, so that's solving with the completing the square. Now this got kind of messy, right? You can see how it got to be a lot of work. There's a lot of fractions involved. So eventually mathematicians were looking for maybe even a better method. Okay, this completing the square always works. I didn't mention earlier, but I should have mentioned, that factoring doesn't always work. You can get problems where you cannot solve it using factoring. There are equations that will not factor nicely at all. This technique of completing the square always works. So if you really like it and you want to use it all the time, it actually works on every single quadratic. You can always use it. It just gets to be messy sometimes. Now, eventually mathematicians said, well, because this works all the time, couldn't we use this just to get a formula? And eventually a mathematician did come up with a formula. So there is a formula for solving quadratics. It is called the quadratic formula. Big surprise, right? So it is a formula we use for solving quadratics, things with an x squared in them. It only works with x squared. You get an x cubed or an x to the fourth, x to the third, x to the fourth. It's not going to work anymore. It only works if it's x squared at most. But it will solve them. And this is the formula. It's kind of big. Thankfully, I'm not going to make you memorize it because it is on the formula sheet. So I got that for you. But this is the quadratic formula. So it will solve and give you x. Notice it does have a plus or minus in it. That way you get both answers because you have to get both answers. And here they're using a, b, c. Well, a, b, c are just these numbers in front of the x squared, the x, and then the c is the number by itself. So all you have to do is look at an equation like this, identify what a, b, and c are, plug them in this equation, and you've got your answer. So let's try it. Let's use this once. So notice on this one, a, in this case, the number in front of the x squared. Well, there's nothing there, but remember there's always a default 1 in front of any x. So we're going to say a is 1. B is going to be the number in front of the x, so it's going to be 8. And c would be that 12 because it's the number by itself, so c is 12. So we're going to plug in 1, 8, and 12 for a, b, and c in this expression. So we get x equals negative b, so we're going to take this 8 and make it negative, so we get negative 8. Plus or minus, we get a big square root, which no matter how big I make this, it's always not quite big enough. So watch, I'll put everything in there, it won't fit. That happens to be like every time. So b squared is going to be 8 squared. So I'm going to have 8 squared, right? So b squared, 8 squared, minus 4 times a, which a is the 1. So I'm going to multiply that times a 1. And then c, which is 12. So I'm going to do times 12. This is the one time where it fits, right? I said that, maybe I made it big this time, but it almost never fits. Okay, on the bottom, we've got 2 times a. So I'm going to do 2, and a is that 1, so times 1. Okay, there's your answer. Well, not really, right? You look at that and you go, that's a mess, right? There's all kinds of stuff going on there. I wouldn't turn that as an answer. If you turn that to me, I'll tell you it's not done. You're not finished. Because you should simplify it, right? And a lot of the work with the formula is actually going to be this process of simplifying. After you put all your values in, that's when the real work starts. Some of it's pretty simple. Some things are easy to do. Like we notice on the bottom is 2 times 1. Well, that's just going to be 2. So that's pretty easy. Up here, you can see 8 squared. Well, 8 squared is 64, so that's not too bad. 4 times 1 is 4, times 12 is 48, right? 4 times 1 is 4, times 12 is 48, that's 48. Don't forget the minus. Negative 8 doesn't change, so we just leave that. Plus or minus, brought that down. So that's a little bit of simplifying, made it a little bit easier. We can do subtraction, right? 64 minus 48, that will solve. So 64 minus 48, I believe it's 16. So we should get 16 in there. Plus or minus negative 8 all over 2. Be careful. Don't try and divide 2 with this root because it's inside a root. You can't do that. So if you try to divide like 16 and 2 right now, it wouldn't work. Also, I see people that try and divide the 8 and the 2 and not this part. Well, the 2 is under everything. So you have to divide everything. So be careful about some of those mistakes. So I'm going to actually simplify this root. This one solves, right? Because square root of 16 is 4. So I can do that. If you can solve the root, you should. If not, you'll have to simplify it sometimes. And then at the end, now I divide both parts by 2. So I could do that, or I guess I jumped the gun. There's two ways to approach this. One, you could divide both parts by 2. The other one is to actually do these addition and subtraction, because you can do it. So I should do that, actually. I'm going to do the addition, do the subtraction. So we get negative 8 plus 4 over 2, and negative 8 minus 4 over 2, because I can actually do that addition and subtraction. Negative 8 plus 4 is negative 4, so we get negative 4 over 2. Negative 8 minus 4 is negative 12 over 2. And then lastly, divide, and negative 4 divided by 2 is negative 2. Negative 12 divided by 2 is negative 6. So all that work, and we finally got the answers for this one are negative 2 and negative 6. Now, it was a lot of work, right? We had to sit there and we had to do all these steps. We had to fill in all the parts of the formula. We had to simplify it. We had to simplify it some more, so do subtraction. Had to do this, divide the root. Had to combine, the top, get the two different answers on the top, and then do the division. All that. And honestly, you could have made this one way easier if you would have just factored it. You look at this and you think, well, multiplies for 12 and adds for 8. Well, it's 6 and 2, right? 6 times 2 is 12. 6 times plus 2 is 8. So you could have just factored this. It would factor as x plus 2, x plus 6. And once you factor it, you can just set both parts to equal 0. So you get x equals negative 2 and x equals negative 6, which is what we got, negative 2, negative 6. And that was a lot less work, right? Hopefully you see why this would be a much better technique. So before you ever use the formula, you should always check to see if it factors. Because if it factors, that's way easier. It's so much less work. So you always want to check, will it factor? If it factors, do that. It's going to be way easier. But they don't all factor. There are times when you'll try and multiply and add and it just won't work. And that's when you go back and you use the formula. Because there are problems that you cannot factor. So if you ever get to a problem, you try and factor and it doesn't work, use the formula. That's the method that always works. In fact, this method works all the time. So I see a lot of people that actually don't really use the completing the square technique. And I'm pretty much okay with that. Any problem I ask you to solve, solve the equation, it's quadratic formula, quadratic equation, I am fine with using the formula on the test and everything, that's fine. But I will warn you, this first problem I gave you right here, with completing the square, notice there's no equation to solve. All you have to do is you have to know how to complete the square. Be ready for a problem like this on the test, because it's a great problem where I can make you complete the square and you have to do it because there's no other technique for solving it. Now, why am I making you do completing the square? Well, there's actually a lot of problems dealing with shapes in algebra and further math that need completing the square. If you have get into any kind of like 3D printing with like circles or ellipses or stuff like that, if you're trying to make a cone or something like that, that actually all deals with completing the square. Some algebra classes spend a lot of time with shapes like circles and ellipses and stuff like that, and you can really heavily use the completing the square technique. So I'm going to make you use it because there are some times when it will show up. We'll see it at least once later on the semester. And if you go into any other kind of math where you end up with those kinds of shapes or working with those kind of shapes, completing the square is a valid technique to have. But I will say, after this exam, I won't make you do any more completing the square. So you just have to be ready for completing the square on the Unit 2 exam. Unit 3 exam, I won't make you complete the square anymore. I will, however, definitely have this quadratic formula show up on the last exam. It's pretty ubiquitous throughout algebra, so you should be ready for that. And again, it's on the formula sheet, so you don't have to figure out too much. You do need to know what A, B, and C are, so you know how to fill it in, and you need to know how to simplify it. So I'm going to do a couple more examples with this, or at least one more example, just so you can get some practice. Be ready, that quadratic formula is important. You'll see it on the exam. Okay, so let's do this one. Now this one you'll notice won't factor. So if I take and say what multiplies for 17 and adds for negative 2, and I try and think, well, the only things that multiply for 17 are 1 and 17. Nothing else works. So 1 and 17 cannot add for 2, or negative 2. You can't subtract for negative 2. So this one will not factor. It won't factor. And since it won't factor, we need to use the formula. Or you can complete the square if you really like completing the square, but I think most of us probably just like to use the formula. And that's fine. I'm totally cool with that. Okay, so let's take this and we're going to plug it in the formula. Again, we have to identify what A, B, and C are. So A, again, there's nothing in front of the x squared, so A is just 1. And that happens a lot. A lot of times A will be 1. That's fine. B is going to be the middle number. Notice this is a minus 2. So B actually needs to be a minus 2, a negative 2. You have to watch the signs here. If you just wrote 2 down here and not negative 2 or minus 2, you'd get a wrong answer in the final answer. So you have to watch the signs on these. C is 17. Again, I got my A, B, and C. I'm going to throw in this equation. So first off, I get x equals negative b, but since b is already a negative, a double negative makes it a positive 2, right? Negative 2 is positive 2. Plus or minus, square root, see if I make it big enough this time. B squared, no, this is negative 2 squared, right? Because b is negative 2. Have negative 2 squared. This is a mistake people make a lot of times. They'll put this in a calculator or do it that way and they'll get negative 4. Remember, when you square a negative, it always becomes positive. If you ever get a negative in this spot in your formula, quadratic formula, you're doing it wrong. This number should always be something squared, so it should always be positive. Okay, then we do minus 4 times a, which we said is 1, so times 1, times c, which is 17, so we multiply that by 17. Okay. I mean, you can do all this stuff and maybe get a negative, but this first part should always be a positive. On the bottom, we have 2 times a, which is still 2 times 1. You'll see a lot of that where a is 1, so that'll be 2 times 1 on the bottom. Okay, next step. 2 plus or minus, it's positive 2, so I'm just going to write 2. Square root, negative 2 squared, well, negative 2 squared we said is positive 4, so it's just 4. 4 times 1 is 4, times 17, so that gives me 40 plus 28, that's 68, so it's minus 68. On the bottom, I want 2 times 1, which is 2. Now I can do my subtraction, 4 minus 68, which gives me a negative 64 under the square root. Still plus or minus, still 2 on the top, and still 2 on the bottom. So that didn't change. Negative 64, well, there you go. I told you imaginary numbers were coming back again. Yeah, so a lot of times you'll have a square root, you'll have a negative in there, which means imaginary numbers. Remember that square root of negative 1 is I, so we could just break this up. We could break it up into, negative 64 breaks up into square root of negative 1 and square root of 64. Well, in square root of 64 we can do, right? Because 8 times 8 is 64, so this becomes an 8, and this becomes an I. So this is 8i, right? 8 times I just like to put the I back. So this actually turns into 2 plus or minus 8i over 2. I'm not quite done yet, because we saw last section. We always want these imaginary numbers written in standard form. So you can't write it as a big fraction like this. You have to divide both parts by 2. So I'm going to write this as 2 divided by 2, plus or minus 8 divided by 2, and I always put that I on the side. Now these divisions actually can work, so I'm not going to leave them in fraction. I'm going to do 2 divided by 2 get 1, 8 divided by 2 get 4. So my final answer is 1 plus or minus 4i. And yes, quadratics can have imaginary or complex solutions. So this can happen. That's one of the main reasons we covered complex numbers last section, is there are a lot of problems where when you solve, you can actually have an imaginary number pop up in your final solution. Most of the time it'll be like this, where it'll show up in the next square root. You just got to remember to pull that negative 1 out of that and turn it into an I. So there you go. That one, we couldn't factor to solve this one, because factoring is never going to give you a weird imaginary number like this, but you can use the formula. And that's what we'll use the formula for a lot of times, is problems where the answers are kind of messy, they're kind of yucky. You have imaginary numbers and stuff like that. You could check this. You could go back and put 1 plus 4i and 1 minus 4i into this equation, but it's going to be a mess. It's kind of a hard thing to check, so it's not a fun one to check. So mostly when you check this, you're going to go back and you should make sure you do all these steps in your work right. It's going to be probably the best check for this. Okay, I got one more page. A little side note page, so it's not something super important, but I just want to show it to you because it does show up in this homework. And it's called the discriminant. So the discriminant is just a really fancy name for the part of the equation that's underneath the square root. So you notice that b squared minus 4a, see, it's the same part that's right here under the square root, because you can look at just that part, just the part under the square root, and you can figure out what kind and how many solutions you're going to get. You don't have to solve the equation to find these. You can just look at that one piece and figure out, oh, what kind of solutions is it going to have? Are they going to be imaginary solutions like we had on the last one? So we had the imaginary solutions. Are they going to be real solutions like on the previous one? Or is there only going to be one solution? And I told you that happens rarely, but it does happen. And you can tell that from this discriminant. So this is the discriminant. Again, it's not super important. I won't test you over this. Discriminant will not show up on the test because it's not that important. Because if you want to solve the equation, you can just solve it, and then you know exactly how many solutions there are. But it's kind of a cool little trick if you want to know without having to solve the entire equation. So to do this, we're going to identify A, B, and C again. Figure out what those are. So A, again, is the first number, so A is 1. B is the second number, so it's negative 3. And C is the third number, so it's 7. So to figure this out, we're going to take this b squared minus 4ac, and we're going to figure out what the solution is. So how we figure this out, we plug those numbers in, and then we decide, is this value going to be positive, negative, or 0? Because the sign of your solution, the discriminant, is going to tell you what's going to happen. If it's a positive number, square root of a positive number will work. You get two real solutions. If it's a negative, square root of a negative doesn't work. We get imaginary numbers, right? So you have your complex solutions or your imaginary solutions. And if it's 0, well, when you square root 0, there's only one solution, right? The only answer is 0, because plus 0 minus 0 gives you 0. So what you do is you actually look at this. You say that b squared minus 4ac, the discriminant, if it's bigger than 0, it has two real solutions. And I should say two unique. They're not the same. So two unique. So we get two different answers. If b squared minus 4ac, if the discriminant is less than 0, it's negative, then you get two complex solutions. And they are also unique. You never get matching complex solutions. And then the third thing is if b squared minus 4ac, if the discriminant is equal to 0, then you get a repeated real solution. That's the one case where you get the same number twice. And so you can sometimes get a quadratic and solve it, and you get the same number twice, and that's because b squared minus 4ac is going to be 0 in that case. Okay, so I started by example before. I should have done this first, but now that I've got this, now let's figure out what kind of answer this is going to give us. So if I throw that in there, so then b squared, that's going to be negative 3 squared minus 4 times a, which is 1, times c, which is 7. If I figure out the sign of this, if it's positive, negative, or 0, then I'll know what's going on. So I'm going to say negative 3 squared is 9. 4 times 1 is 4, times 7 is 28. So get 9 minus 28, which is negative 19. I could just say is less than 0, right? Because with 9 minus 28 is going to be less than 0. It's going to be negative. And as soon as it's negative, even if I don't know what the number is, I know what the solutions are like. Now, this won't give me a solution. So if you solve this and get negative, 19, that's not the answer. Negative 19 is not the answer. But you'll know what kind of answer you have. This just tells us that there are two complex solutions. There's two solutions with i's in them. That's what this is telling us. And you can see how it's not the most useful thing ever, because it didn't give us the answers. It just told us what the answers look like. And there might be certain cases where you might just want to know if the answers are real or imaginary. If you're the electrician, the engineer, and you're saying, hey, I need a number that I can use for length of my cable, I'm not going to really use these complex solutions. You're going to have to figure out how to go back and get a real number instead. So that might be handy for them, but we're not going to really use this in our class so much. I'm just going to tell you, here, take the equation and solve it, throw it in the formula, get an answer, and then you'll tell me what the answers are. That's going to be handier for us most of the time. But that's the discriminant. It does show up in this homework. I wanted to make sure I showed it. There are times in further levels of mathematics, like if you go into higher levels of mathematics, you might see it pop up here or there. I know I saw it in grad school at least once or twice. So I wanted to introduce it, but I'm not really worried about it for the exams or anything. So you won't worry about that. You definitely should be able to use the formula. Like I said, to solve equations that you can't factor. You should be able to complete the square and factor, like we did here. You'll see that in the homework. And you should be able to use the square root property, because that can show up, or factor. And again, factor can be the easiest method. There's a lot of times factor is the easiest method. But all those are just different ways to solve quadratics. And we'll do a lot of solving quadratics from here on out. So that's it for this section. We'll see you on the next set.